While I was trying to forcefully remove a header attached on motor driver module that I used in RC toy car, my thumb was pressed against a surface mount capacitor, which I soon realized was not a good idea. Both solder joints broke and capacitor came off the PCB. Circuit diagram of motor driver module was not readily available. Hence, I used my multimeter in connectivity mode to create it. Detached capacitor was connected between input and ground lead of IC named 7805, which is a 5V linear regulator. According to regulator's datasheet, this capacitor is called bypass capacitor. They recommend it in cases where regulator is located at an appreciable distance from power supply filter or battery. This bypass capacitor is a small local reservoir of charge. It can momentarily supply stored charge to regulator in case of sudden increase in load current. Without bypass capacitor, increased current has to come from distant power source, which can result in voltage dip because of supply and wire resistance. Bypass capacitor is like a small water bottle at your desk. This prevents you from walking to nearest big water supply every time you are in need of water. Once bottle is empty, you have no choice but to charge your capacitor. Let's charge a capacitor. In our first setup, we have a 1 kΩ resistor in series with 2200 microfarad capacitor. And I will charge this capacitor using a constant voltage supply of 5V. As we don't have an oscilloscope in mini project lab yet, we will use Arduino serial plotter to look at capacitor voltage waveform. Voltage across capacitor rises rapidly first and then slows down. Mathematically, this curve is represented by this equation, which translates to this in our case. After about 2.2 seconds, capacitor voltage equals 3.161 volt. And after about 10 seconds, capacitor voltage approaches 5 volt. Let's write down capacitor voltage equation one more time. There is a mathematical constant, E, called Euler's number in this equation. Why is it in this equation? Why not some other constant, like pi or I? Euler's number is an irrational number, which equals 2.71828 and so on. It never ends. Jacob Bernoulli in 1683 discovered this number while studying a question on compound interest. An account starts at $1 and pays 100% interest per year. If interest is credited once at the end of the year, value of the account at end of the year will be $2. What happens if interest is credited more frequently during the year? If interest is credited twice a year, the interest rate for each 6 months is 50%. This results in $2.25 at end of the year. Compounding quarterly results in $2.44, and compounding monthly results in $2.61. Jacob Bernoulli noticed that this sequence approaches a limit with large number of intervals. Compounding weekly results in $2.69. Compounding daily results in $2.71, just 2 cents more. The limit as n grows large is the number that came to be known as Euler's number E. With continuous compounding, the account value will reach $2.71828. Well, the point is, we use Euler's number to represent how natural growth behaves. There are no intervals in nature. It's like a flow, continuous. The curve e raised to x is a curve of continuous natural growth, and e raised to minus x is continuous natural decline, which is what happens to potential difference across resistor that decides capacitor charging current, and hence E in the equation of capacitor voltage. We can still charge capacitor with different profile if we don't let charging current naturally decline. Let's charge a capacitor using constant current source. We can create a simple constant current source using LM317 and a resistor. My constant current source is of around 1 milliampere. Hence, it should charge 2200 microfarad capacitor to 5V in around 10 seconds. Let's end this video by taking a look at capacitor charge using constant voltage and constant current source in Arduino serial plotter.